Renuka Services and Technology Private Limited has organized a webinar on quantum mechanics, boson particle, in the memories of Satyendra Nath Bose on the 12th of January 2021. Quantum mechanics is a fundamental theory in physics that provides a description of the physical properties of nature at the scale of atoms and subatomic particles. It is the foundation of all quantum physics, including quantum chemistry, quantum field theory, quantum technology, and quantum information science. In simple words, a study of structure or form of small portion like atom is called as quantum mechanics. Basically, boson particle is who, which follows Bose-Einstein statistics. Boson make up one of two classes of elementary particles, and the other being fermions. The name boson was coined by Paul Dirac to commemorate the contribution of Satyendra Nath Bose, an Indian physicist and professor of physics at University of Calcutta and at University of Dhaka in developing with Albert Einstein Bose-Einstein statistics, which theorizes the characteristic of elementary particles. Examples of bosons are fundamental particles such as photons, gluons, and W and Z bosons, the four force-carrying gauge bosons of the Standard Model, the recently discovered Higgs boson, and the hypothetical graviton of quantum gravity. Some composite particles are also bosons, such as mesons, and stable nuclei of even mass numbers such as deuterium, with 1 proton and 1 neutron, atomic mass number equals to helium-4, and lead-208, as well as some quasi-particles, e.g., Cooper pairs, plasmons, and phonons. An important characteristic of bosons is that there is no restriction on the number of them that occupy the same quantum state. This property is exemplified by helium-4 when it is cooled to become a superfluid. Unlike bosons, two identical fermions cannot occupy the same quantum state. Whereas the elementary particles that make up matter, i.e. leptons and quarks, are fermions, the elementary bosons are force carriers that function as the glue, holding matter together. This property holds for all particles with integer spin, s equals 0, 1, 2, etc. as a consequence of the spin statistics theorem. When a gas of Bose particles is cooled down to temperatures very close to absolute zero, then the kinetic energy of the particles decreases to a negligible amount, and they condense into the lowest energy level state. This state is called a Bose-Einstein condensate. This property is also the explanation for superfluidity. Bosons may be either elementary, like photons, or composite, like mesons. While most bosons are composite particles, in the Standard Model of particle physics there are 5 bosons which are elementary. The Standard Model requires at least one scalar boson, spin equals 0 H0 Higgs boson. The 4 vector bosons, spin equals 1, that are the gauge bosons for the Standard Model gamma photon G, gluons 8 different types. Z neutral weak boson W plus or minus charged weak bosons 2 types. There may be a 6th tensor boson, spin equals 2, the graviton G, that would be the force carrier for gravity. It remains a hypothetical elementary particle since all attempts so far to incorporate gravitation into the Standard Model have failed. If the graviton does exist, it must be a boson, and could conceivably be a gauge boson. Composite bosons, such as helium-4 atoms, are important in superfluidity and other applications of Bose-Einstein condensates. Instances of a boson have no quantum mechanical obstruction to occupy the same state. Bosons are often force carrier particles, including composite bosons such as mesons. Force carriers are also said to be the particles that transmit interactions, or the constituents of radiation. The properties of lasers and masses, superfluid helium-4 and Bose-Einstein condensates are all consequences of statistics of bosons. All known elementary and composite particles are bosons or fermions, depending on their spin. Particles with half-integer spin are fermions, particles with integer spin are bosons. In the framework of non-relativistic quantum mechanics, this is a purely empirical observation. In relativistic quantum field theory, the spin statistics theorem shows that half-integer spin particles cannot be bosons and integer spin particles cannot be fermions. All observed elementary particles are either fermions or bosons. The observed elementary bosons are all gauge bosons, photons, W and Z bosons, gluons, except the Higgs boson, which is a scalar boson. Photons are the force carriers of the electromagnetic field. W and Z bosons are the force carriers which mediate the weak force. Gluons are the fundamental force carriers underlying the strong force. Higgs bosons give W and Z bosons, and other particles, mass via the Higgs mechanism. Their existence was confirmed by CERN on the 14th of March 2013. Finally, many approaches to quantum gravity postulate a force carrier for gravity, the graviton, which is a boson of spin plus or minus 2. Composite particles, such as hadrons, nuclei, and atoms, can be bosons or fermions depending on their constituents. More precisely, because of the relation between spin and statistics, a particle containing an even number of fermions is a boson, since it has integer spin. Examples include the following. Any meson, since mesons contain one quark and one antiquark. The nucleus of a carbon-12 atom, which contains 6 protons and 6 neutrons. The helium-4 atom, consisting of 2 protons, 2 neutrons and 2 electrons, also the tritium atom, consisting of 1 proton, 2 neutrons and 1 electron. The nucleus of deuterium, known as a deuteron, and its antiparticle. The number of bosons within a composite particle made up of simple particles bound with a potential has no effect on whether it is a boson or a fermions. Bose-Einstein statistics encourages identical bosons to crowd into one quantum state, but not any state is necessarily convenient for it. Aside of statistics, bosons can interact. For example, helium-4 atoms are repulsed by intermolecular force on a very close approach, and if one hypothesizes their condensation in a spatially localized state, then gains from the statistics cannot overcome a prohibitive force potential. Bose-Einstein statistics for a material particle is not a mechanism to bypass physical restrictions on the density of the corresponding substance, and superfluid liquid helium has a density comparable to the density of ordinary liquid matter. Spatially delocalized states also permit for a low momentum according to the uncertainty principle. Hence for low kinetic energy. This is why superfluidity and superconductivity are usually observed in low temperatures. Satyendra Nath Bose was an Indian mathematician and physicist specializing in theoretical physics. He is best known for his work on quantum mechanics in the early 1920s, collaboration with Albert Einstein in developing the foundation for Bose-Einstein statistics and the theory of the Bose-Einstein condensate. A Fellow of the Royal Society, he was awarded India's second highest civilian award, the Padma Vibhushan in 1954 by the Government of India. In 1937, Rabindranath Tagore dedicated his only book on science, Vishwa Parichay, to Satyendra Nath Bose. Bose was honored with title Padma Vibhushan by the Indian government in 1954. In 1959, he was appointed as the National Professor, the highest honor in the country for a scholar, a position he held for 15 years. In 1986, the S.N. Bose National Center for Basic Sciences was established by an Act of Parliament, Government of India, in Salt Lake, Calcutta. Bose became an advisor to then newly formed Council of Scientific and Industrial Research. He was the president of Indian Physical Society and the National Institute of Science. He was elected General President of the Indian Science Congress. He was the Vice President and then the President of Indian Statistical Institute. In 1958, he became a Fellow of the Royal Society. He was nominated as member of Rajya Sabha. Swami Vivekanand Narendranath Datta was an Indian Hindu monk. He was a chief disciple of the 19th century Indian mystic Ramakrishna. He was a key figure in the introduction of the Indian philosophies of Vedanta and Yoga to the Western world, and is credited with raising interfaith awareness, bringing Hinduism to the status of a major world religion during the late 19th century. He was a major force in the revival of Hinduism in India, and contributed to the concept of Indian nationalism as a tool to fight against the British Empire in colonial India. Vivekanand founded the Ramakrishna Math and the Ramakrishna Mission. He is perhaps best known for his speech which began with the words, "Sisters and Brothers of America," in which he introduced Hinduism at the Parliament of the World's Religions in Chicago in 1893.
We are very grateful to see you attending this webinar. We express our feelings towards you simply by saying thank you.